Actually, she had taken digital camera using 8051. Okay, so not like a olden days. We don't have a camera just like a film roll and all. Nowadays, we can able to see in the LCD screen, and we have a capable to store the data. And similarly, we can able to send the data, and we can store it in a SD card. So many facilities are available in the camera, not like olden days. Okay, so we can able to delete, we can crop, we can change the background, everything we can able to do it. Nandini,
Yes, ma'am.
yeah, will you start talking, ma?
Oh, yes, ma'am.
Yeah, proceed, Nandini.
Hello, everyone. I'm going to explain the digital camera. Digital camera is the example of embedded system. In digital camera, first image is captured and converted to digital form. This digital image is stored in internal memory. It has the analog to digital converter, image processor, memory, lens, communication interface. It consists a lot of components, including DSP processor, has the own processor, sensor, actuator, and also memory for storage purpose. Ma'am, next slide, ma'am. Why we want embedded system in digital camera means first thing is data collection, data storage, data representation. Ma'am, next. Working of the camera means first of all the CPU is the main processor. It's also connected with the various other processor. It has the four tasks: data collection, data storage, data representation. Lens. Lens means we adjust and modify the lens. CCD means charge coupled devices. There's the charges. It is the analog value, convert the digital form. The focus object brought to the CCD, then DSP. The camera DSP processor, the image taken by CCD camera, after it is converted to digital form. The analog video stream are generated by the charge coupled devices or CCD chips, which DSP chips that convert into digital form. Advantage of DSP in camera means first of all increased brightness, ordered stability, resolution, greater sharpness, greater power efficiency. Then data storage, store the data in whether flash, RAM, memory card.
Varudhu sir.
Store, store the information processed by JBG coprocessor. The JBG coprocessor mainly meant to compress and decompose image into JPG format. Then graphics control. This used to make the video. The right side of the CPU used to do communication. Either you want to see photo in LED or LCD panel at the time of snapshot. Once you take snapshot at the display, you will see whether it is expect the quality or it is not means take the restart. The purpose only we have input output control. Then the IRTA interface provided for remote controlling of the camera through the infrared remote. The Ethernet connection is the serial port. Interface is given for the Ethernet connection. There are other interfaces like RS-232 and Bluetooth for advanced communication support. This Bluetooth used for the remote control. You can operate the camera with the help of the Bluetooth model. This used to try the put timer mode, auto zoom, used to click. This thing happen in the Bluetooth model. Then camera is also used for the video mapping. The information from the graphics controller will come to the video decoder and make it visualize the video in LCD or LED panel. And that's it.
Yeah, very good, Nandini. Actually, she had taken the different side of applications that she have explained with the DSP processor. I think so. Here, CPU is a DSP processor, or 8051, because RS-232 Bluetooth module and all. I think they are using DSP processor. I think so, Nandini. Am I correct or not?
Yes, ma'am. Yes,
Yeah, actually, what DSP processor you have learned in your previous semester in digital signal processing in sixth semester? you have learned one processor, TMS 320C 6407. Actually, this is a Texas instrument. Okay, so they have manufactured the DSP processor. So the DSP processor having all this memory unit and the communication protocols, and then it have a co-processor as well as some graphic controller and all. So she have explained with this diagram. Very good, Nandini. Good. Okay, ma. Okay. How many students were came? Yeah, still 71. Vijay Shri. Vijay Shri,
Yes, ma'am.
are you ready, ma?
Yes, ma'am.
Okay. Shall I will allow you to share the screen.
Yes, ma'am.
Now, can you check whether you can able to share screen or not?
Yeah, 1 minute, ma'am. Yes, ma'am.
Hmm.
Can you see, ma'am?
Yeah, I can able to see.
Good morning to all. Today I am going to explain one of the 8051 microcontroller application that is on spying robot. The name only says that it is used for spying. We all know that 8051 microcontroller is 8-bit data and 16-bit address. It's one of its application is already told spying robot. This is mainly is used in the military for spying for the enemies. Most of the times it is used in war times. We don't know what the enemies on the other side are going to do and what their plans are next. So we want to get an idea, so we are using the spying robot in order to capture the images and monitor in the system, so we will be getting alert. The main working principle of this robot is the robot will capture the image and this will be transmitted and it will be received in the receiving unit and it will be monitored in a TV. Next, the main parts are sensor unit, receiver unit, actuator, and control unit. Sensor unit. To capture any image, we need light. So during the night time, we don't have any source of light. So we use IR LED light. As we know that every object emits IR radiation, by this we can capture the images. By the AR radiation light, we can capture the images even during the night time also. Next, receiver unit. Robot consists of receiver unit to receive the controlling unit, and thus robot will move forward or backward direction. Next, actuator. We know that actuator is a machine that is responsible for moving or controlling of a system. So here in this robot, actuator consists of two DC motors used for moving of a robot. Next, controlling unit. As this spying robot is human remote controlling part, and here the camera is wireless. So this controlling part consists of encoder, RF module, microcontroller, and a decoder. Next we'll come to working processor. Here we have 12 volts DC, so DC battery and night vision wireless camera and receiver unit to the TV. The camera will capture images and this will be transmitted into the digital signal by a transmitter unit. In the receiver unit, it will receives and there it will the digital signals are converted into the image format and this image format will be monitored in a TV. This is the block diagram of the transmitter side. This transmitter consists of an encoder, will get an parallel data from the microcontroller and this will get an parallel data from the push buttons. For example, in the push buttons, if we give any left or right, then it will be this data will be transmitted to microcontroller and this parallel data will be transmitted to encoder saying that to move the robot on the left side. This parallel data will be converted into serial data via RF module transmitter. This will be transmitted to the receiving end via the antenna. This is the block diagram for the receiving end. So we are getting the serial data from the transmitter side, and this will be received in the RF receiver. Now this serial data is converted into the parallel data by the decoder. Now the microcontroller will accepts the serial data, and this gives the command to the motor to move the robot in the forward or reverse direction. According to the commands of the microcontroller, the motor will move. So this is an overview of what I told. First, push buttons will give commands. It will convert it by using the encoder. Next, RF transmitter. Now, as I already told, that camera is wireless, so we can capture the images by more than from the 30 meters away from the receiving unit. Now this RF receiver will receive it, and it will be decoded, and it will be sent to the motor driver, and two motors will, and DC motors will move forward or reverse direction. The main advantage of this is it is very low cost, and it saves many life in emergency. One of the main disadvantages, as we are using very low DC supply, that is 12 volts or 6 volts, the power saving battery is not there. So in order to improvise it, we can use any power saving battery to to save more cost, to save less cost, and we can use for longer time. Thank you, ma'am.
Yeah, thank you, Vijayshri. Actually, she have taken the another way of applications of 8051 spying robot. See, if by searching that you can understand that, even though while we are taking classes we were saying these are the applications are that, but while going in depth, you all see that all ports are have been connected. Serial communication module will play a important role, and analog to digital converter, digital to analog converter plays an a role. So timer and counter also plays a role. So whatever the peripheral devices we have studied in the embedded controller, by in the application point of view we were seeing, so the code we can able to diffuse in the microcontroller, and we can able to execute the program. So she had explained, actually, Nandini and as well as Vijayshri both have taken in two extreme ends, but we can able to gather. Even I am saying that I have seen one nearly some applications related to that, but by seeing nowadays I can earn more knowledge on what are all the other sides of the microcontroller applications. I can able to understand. So thank you, students, and you may also gather knowledges, and you know why for each and every subject it's always correlated with one another, that you are in final year you can understand encoder decoder. She's saying that we have learned in digital logic circuits. Okay, so while we are working of studying analog to digital converter, digital to analog converter, you are studying in linear integrated circuits. So motor concepts, now you are studying that motor concepts in machines, DC machines and transformers. So while you are studying about any regulator and all, you are studying in electron devices. So the electrical people can only do all the end of the thing. We were studying from electricity to still now, the in our branch is our Shanmuga. What you are sharing? Shanmuga has started sharing the screen. Yeah. Yes.
By mistake, ma'am. No,
By
ma'am, by mistake.
yeah, no problem, Shanmuga. So you understand that
Okay, ma'am.
we are the versatile electrical engineer. We can capable to do all kind of job, even in software also we can able to write the coding also. So the thing you what you're learning in the branch, even though they were saying very boom technology in computer science and all, that people can't able to adapt only in the software field, but we can different think in different journal. So I gave you the embedded system applications to identify, to do that and all. You people were doing very excellent. So nearly some 13 students have taken a seminar. So I think we will call one more students, and then I will take seminar, sorry, and then I will take class, then we will see at the end. Okay, so I gave to that, who is else, and Neetu Priya. Neetu Priya. Neetu Priya is not present today. Yes.
Ma'am, I'm here only, ma'am.
Yeah, Neetu Priya, can you able to take now?
Ma'am, I'll take at the end. Actually, I've got power cut now, ma'am. So if I share screen, it won't come. I'm using my mobile data, ma'am.
Okay. Then okay, leave it, ma. So I will call. And so you are ready only, Neetu Priya.
I'm ready, ma'am.
Yeah, okay. Then Nilofer, Nilofer, Nilofer Yasmin.
Tomorrow, ma'am.
Tomorrow, okay. Pandiyarajan, Pandiyarajan.
Ma'am,
What?
Monday எடுக்கிறேன் ma'am.
Okay, Monday. Yeah, no tomorrow. Tomorrow you don't have a class.
Yes, ma'am.
Parameshwari.
Ma'am,
Yeah, what Parameshwari?
ready, ma'am.
Ready. Okay. So Neetu Priya and Parameshwari will take at the end. Are you clear? Or else will you take
Okay,
now?
At the
Let end. Okay. You both take at the end. And one more thing I have to call Avinash and Balashankar. Avinash,
Yes, ma'am.
whether you have prepared,
No, ma'am.
why? Hey man, this is one of the exposure only I'm taking this subject and I'm teaching for you. I'm saying RS-232 cable and all. And now one of the seminars she have explained RS-232 and a Bluetooth model they are using as a serial communication module to transfer the data to system or to that. So I think you can improve your knowledge. Try ma. Bala Shankar. Next Monday you'll take Avinash.
Okay, ma'am.
Balashankar,
Yes, ma'am.
are you ready, man?
Ma'am, actually, day after tomorrow, my cousin marriage, ma'am. So that's why I don't have get time to prepare for that. Next week,
Nowadays, marriage is happening only with 50 or 60 only. Not like due to that. Okay, anyway, you are
next
in
week.
a family function mode. Okay, so leave it. I can't able to identify the person. I can't able to tell. Bharat is not present today. Okay, leave it. So I'll remember the next week, Avinash. On Monday, I'm saying. Okay. Avinash, Bibu Anand, he is not present today. Chandralekha, what happened to all?
Yes, ma'am.
Chandralekha, you'll take on Monday.
Okay, ma'am.
Okay. Shushant, will you take on Monday, Shushant?
Ma'am, I cannot prepare that, ma'am. I don't
Why?
have laptop to prepare.
No problem. You can have a mobile and all, na?
Yes, ma'am.
Then what you do, you take all screenshots. Okay. It's clear,
Yes,
ma? And then you convert into PDF or PPT. You send to my mail ID. Are you clear? I told you only 3 PPT is enough. Sorry, 3 slides is enough. Not more than that, I have told you. Only 5 minutes of time. Yes, Shushant, you try. You try your
Okay,
best.
ma'am. Yes.
Deepa K.
Yes, ma'am.
Will you take on Monday?
Yes, ma'am.
Okay. Deepa S. Deepa S. She's absent today. She's present only. Deepa S.
Yes, ma'am.
Any network issue will come for you. Will you take on Monday, Deepa
Yes,
S?
ma'am.
Okay. So you all
Yes.
remember on Monday, Avinash. Okay. And Chandralekha, Shushant, Deepa K, Deepa S. Yes. And one more thing. Moganapriya, are you here, Moganapriya? Moganapriya. Actually, she tried to take. Now you are ready, huh, Moganapriya? Or else, or at the end they will take.
Yes, ma'am.
Okay, you ready with your PPT? At the end, you will share and take. Okay. So now,
Okay, ma'am.
yeah, ma. So Moganapriya, then who else I told you? Parameshwari and one more Neetu Priya. Okay. Actually, I will till take 9:40. The 10 minutes sir is in another class. He will take some time to come. So 9:25 itself, I will give for seminar. You take till 9:40. Are you clear? 3 of them be ready. And now I will share the PPT for you. Okay. So what we discussed in last class, mom? What we discussed in the last class? Anyone please tell ma what we were discussing? Yes. Yeah. No one have remember what I have taken in previous class. Hey man, Chandralekha, what I have taken previous class?
Can, ma'am.
Yeah, controller area network can I have taken. Okay, so remember all the serial protocol RS-232, RS-485 we have completed. Then controller area network also completed. Today we are going to see inter-integrated circuits, I square C. Okay, so I think SPA, USB, Ethernet, that we will discuss in the next week. So probably we will complete next week. And one more important announcement for you. Please kindly submit the assignment. Are you clear? That's why I insist each and every people to prepare a seminar. You be ready. We will do till the end of the thing. Or daily 2 or 3 students we will call upon and we ask them to present seminar. And I have seen you. It will increase your confidence level also. Can you understand or not? Okay, that will take around some 2 hours for you to prepare. So just spare it and try to prepare. Okay, ma. So today we are going to see the another serial protocol I square C, integrated circuit bus. Are you clear, ma? I think. Wait. Okay. So integrated circuit bus, I square C. Okay. So this I square C is developed by Philips Semiconductor 1980. They have only developed. And did you remember who have developed CAN controller, ma? Anyone remember? Who is developed CAN controller at starting?
Motorola, ma'am.
No, Robert Bosch. You forgot. CAN is developed by Robert Bosch initially. Then after that, Intel and Philips comes over. But when you see CAN is developed by Robert Bosch, RS-232, RS-485 developed by EIA standards, and I square C is developed by Philips Semiconductor. See, they developed in the year of 1980. But when it comes into the proper usages, it takes some nearly 10 to 15 years. All the standards has to accept this particular protocol. Okay. Now, where I square C is used. Actually, you have seen I square C use always the concept of master and slave. How we have seen various ECU unit will be there and CAN bus will be there. Na? Similarly, here also I square C bus will be there. One master. Master will be the microcontroller. And all my slave devices. Here, the devices which is connected with the I square C buses is I will connect various processor. Okay, or that processor or slave processor. Whatever I am connecting in I square C buses, that are all called as a slave devices. Okay, EEPROMs, sensors, real-time clocks, that and all I will connect. So you have seen that I square C will be the length which will be used will be less than 1 meter. It will be equipped only in a particular instrument or rod. So not like RS-232, it cannot be used like that 50 feet. And in CAN bus also, we have seen it is employed in power trains or the car body and all. But I square C bus, it's mainly used in a portable instrument or some of the instrument where the devices like sensors, real-time clocks, analog to digital converter, digital to analog converter, memory cards, there only we will use I square devices. But wherever I am connecting my I square devices, all the devices are slave devices. Only one control, that is my master control. Okay, so I square C in application wise, they are saying that digital TV tuners, video decoders, audio processors, and all they will use. So the Philips Semiconductor, we all know Philips is the olden days. It's a popular manufacturer in the television. So they have developed this I square C bus. Now this will be used in TV tuners, video decoders, audio processor, and all. Okay, I square C bus. how we can classify now? The way we are classifying is slow, fast, high speed. We all know RS-232 now, it can transfer maximum 20 kilobit per second. Okay, and when you go with CAN, it have a two category, power CAN and we used to say basic CAN. So while we are seeing with that, one will transfer greater than 250 kilobit per second, another CAN will transfer greater than 150 kilobit per second. But I2C is having three kind of speed: slow I2C, fast I2C, high speed I2C. Slow I2C na 100 kilobit per second, fast I2C na 400 kilobit per second, high speed I2C na 3.4 megabit per second. Okay, that's we are saying the version 2 2.0. Okay, I2C v 2.0. Okay, bus length I already told, it is only available inside the equipment, so the depending upon it will be less than 1 meter. So I2C is a serial communication protocol which is developed by the Philips. It is mainly used inside the equipment, so it will be used only less than 1 meter only I can able to use. Depending upon the speed, we have a three category of I2C buses. Okay, and mainly when you see with all digital TV tuners, decoders, processors, audio processors, EEPROM memories, sensors, real-time clocks and all we will use. So whatever I am connecting I2C, the particular devices are called as a slave devices. Only one control, that is my master microcontroller. Okay, so that's all about introduction about I2C. Okay, what is I2C signals? What are the signals are there? Actually, when you go with I2C, we have a only two line. You have seen, this is my master and this is my slave. I told you there are so many slave devices will be there, but for your purpose, I have taken only single one and I am explaining this. So in subsequent slides, you will see in detail. Okay, we have a two lines. Actually, I2C you having only two lines. What are the two lines now? SDA. Remember, it's very important point. SCL. What is SDA na? Serial data line. What is SCL na? Serial clock line. So only these two lines only there, and you all understand it is a bidirectional communication. That means what? It's a full duplex communication. You all understand? RS-232 also full duplex. RS-445 is half duplex. CAN is also full duplex, and when you go with I2C, that is also full duplex. That means it have a bidirectional communication. So we have a two lines here, serial data line and serial clock line. We have a two lines here, serial data line and serial clock. So how many slave devices I can connect? So we were saying that nearly 128 devices I can connect with a clear communication pathway. Clear communication pathway in I2C, I can connect nearly 128 devices. So in that 128 devices, what are the devices can I connect? They were saying microcontroller is always fast, but when you see with peripheral, that are all slow devices. So they were saying that some low speed devices like EEPROM, AD, some microcontroller means that will be slave microcontroller. Are you clear? Digital to analog converter, you I can able to connect with that. So they are saying the other related with this are UART, SPI or I2C. Okay, so now you have a concept of I2C with pull up resistors. Have you heard the word pull up resistors anywhere, ma? I2C lines will use pull up resistors. Where you hear this line pull up resistor?
Ma'am, in unit 1 and 1 port we heard, ma'am.
Very good, very good. Who are telling this answer, ma?
Neetu Priya, ma'am.
Neetupriya, very good, Neetupriya. She said very correctly. Actually, while we are seeing with ports, while switch on and off, we were saying the logic 1 is available, logic 0 is available. So to off the particular devices, we have a pull-up resistor. So what the pull-up resistor will do and all, na, it will take the high voltage and it will transfer the low signal to the ports. So that is pull-up resistor concept. So here also, you just see this is my I2C bus configuration. So you have seen my control, central microcontroller or master microcontroller. Okay, we have only two wires. What are the wires, ma? One is serial data line and another one is serial clock line. You all understand? We have only two lines, serial data line and serial clock line. Okay. And peripheral devices, I can use all the peripheral devices like that. So now, actually, they were saying, actually we can able to send the communication to the multi-master buses that there. At that time, it will act as an a half duplex. Multi-master means what? More than two masters are available at that time. It will act as an a half duplex. Otherwise, it will do the full duplex communication. Okay. Now, I told you same concept. Two bus lines will be there. Master slave concept will be there. Multi-master bus is also available there. And then it all know it will 8-bit data only it will transfer. Then we have seen low speed, medium speed, high speed, I square CV bus na. So that's why they have classified standard mode, fast mode, and high speed mode depending upon the bits per second transferred. Okay. And the maximum bus capacitance is 400 picofarad. Why we are taking this capacitance and inductance value now? The capacitance and inductance also influence the speed of the bus. So mainly we have to see. I think you have studied this capacitance and inductance. Where you have studied now? Where you studied, ma? To measure the cable of capacitance, inductance in a cable or in solenoid or else in any transmission lines. Where you have studied this topic? Can you tell? Anyone tell? Did you remember? At which subject you have studied this? I'm asking only.
PLC, ma'am.
Hey,
Electromagnetic theory, ma'am.
electromagnetic theory. Whether I thought for you. In EMT only, we used to measure how to measure the capacitance value in a cable, how to, that will be single coaxial cable and all. You have seen so many category. So there we studied the how to measure the capacitance, and here we are studying the influence of capacitance also makes the speed of the bus lower. Okay, due to some interference. Okay, now the next one is, okay, and now can you able to see them, master pick microcontroller? Any microcontroller they will use. So they connected three slave devices. One is temperature sensor, and another one is real time clock, and another one is LCD display. So this is my I square C buses. You all know I square C buses having only two lines. What are the two lines, ma? I square C bus, what are the two lines in I square C bus?
STA, SCL, ma'am.
Very good, very good. SCL, serial clock pulse. That's why we are giving clock input here. The yellow color line indicates serial data line and green color line indicate clock pulse. Okay. And you all see, this is the way they will connect I square C bit. This is nothing but multi-master diagram, and this is a single master diagram. Are you clear, ma? Here two masters will be there, two slaves. So it is a multi-master concept. But here a single master. I told you maximum how many devices I can connect. How many devices I can connect, ma? Now only I told.
128, ma'am.
Yeah, very good. 128 devices I can connect. So this is in pull-up resistor. So pull-up resistor restore the high to the wire when no devices is pulling to low. That means if no devices are on and all, automatically the pull-up resistor will be load the value to high. So this is that why we have seen in ports. So master device, all the slave device, two lines will be there. So to restore the signal, we always use the pull-up signal, pull-up resistor. Okay, now you just come into the our way. That is nothing but I square C, how it is working. That is very, very important, because while we are saying that I square C, I have a master device, so many slave devices there, all the device will be connected. So nearly I am saying 128 devices is connected, but I have to identify how you are having a roll number or register number for you to identify you as a person. The similar way, all the slave devices having a address. So what happened now? The master generate the address where which device has to control. So automatically slave will check with the address. If the master sends the address to all the slave devices, whether my slave device address is accept, it will send the acknowledge signal. Similarly, if I am calling Aruna Devi register number 11, she respond, yes ma'am, that is the same way. I am conveying to register number. Everyone checking your register number. Your number is not 11. The 11 is only the Aruna Devi number, and she is responding immediately. That is the acknowledgement. Can you understand? So this is the way we have a communication between master and slave. So my master address, sending address should match with the slave address. Then only the particular slave device will sends the acknowledge signal. You all understand? All the serial protocol having start, end. Can you understand or not? Start condition and the end condition is very, very important. Whether my communication is over or not to the particular frame, that will be there. Can you understand? Okay. And now we are going to see the I2C communication protocol. You all understand each and every communication having separate protocol. It doesn't match with the other protocols. Are you clear or not? Fun thing is RS-232, yesterday only I told you. What are the message frames are there, ma? In RS-232? RS-232? What are the message frame?
Standard data frame, extended data frame.
No, that is you're saying in CAN micro. I'm asking what are the how I can say how it will transfer the message and what are the message contains. RS-232 doing UART communication. Then tell me what are the bits available. Yesterday I have written and explained.
Start bit, ma'am.
Start bit, stop bit, very good. In
Data
between,
bit, parity bit, ma'am.
yeah, very good, very good. Start bit, data bit, parity bit, stop bit. Okay. Can I think very big thing. At least tell few of can protocol. Can messages contains what are all there?
Data frame, remote frame, ma'am.
Start frame.
Error and overload.
No, you forgot. I have taken a very big time to explain.
Ma'am.
Start of frame, end of.
Arbitration, control field, data field, CRC field, acknowledgement, end of frame, ma'am.
Very good, very good, very good. Actually, Aruna Devi, I have to tell you that she is taking the notes. That's why she is spontaneously responding to my answers. Some of them were not having notes, just listening. You all know we are all having a human memory. Okay. So what is the thing is, we have our memory is not much. It can't able to store all the data. So the hints are very, very important for you to answer my question. I think no, I think some only 2 or 3 students are taking the answers, notes. The others are simply seeing. Some of them were just to switch on the video or switch on the class and they went somewhere else. Remember one thing is, you are in final year, you have a capability to handle each and everything. So while you are going to work from next year onwards, I can't say next year, am I correct? Yeah, 2021 next year onwards you'll work. So you people have to handle that kind of thing. How what the manager said, they won't ask what I have said in the previous. They ask you what is the status. Are you clear? So you have to go to that mode. So be prepared and be enthusiastic. Then only you can able to achieve something in your life, or else the life will not move as it is. Okay. So start of the frame, end of the frame, acknowledgement, cycled redundancy check. I told you 64 bits will be transferred here, and data length code, then RTR, it's nothing but a remote transmission request, and identifier extension. So this is 11 bit and this is a 29 bit. Okay, so this is for CAN protocol, but I2C protocol is separate. Are you clear, ma? You all understand what are the thing available in I2C protocol? Start. All understand start condition. Okay. Start condition. Then stop condition. The next one is address of the slave. I have to, my master has to know at which slave device I have to communicate. So I have to handle the address of the slave. Whether I am reading from the slave device or I am going to write into the slave device. That is read write bit. Then data frame. We all know it will transfer only 8-bit of data. So D0 to D7, 8-bit of data. That is my data frame. Then acknowledgement bit. So the first acknowledgement bit is slave device is accepting this is my slave address. That is the first acknowledgement which is acknowledged by the slave device after the address of the slave device. And the next one, the last one is when it receives the data also, it will send the acknowledgement. So we have a 2 acknowledgement bit. One is after receiving the address, then after receiving the data, we have a 2 acknowledgement bit. And the next one is it is not acknowledged na NACK bit. Then stop condition. I think it is very easy for you people to remember the communication protocol. That is start condition, stop condition, address of the slave, then the data, whether we have to read the data or write the data, and similarly acknowledgement bit after the reception of address, after the reception of data also we have a acknowledgement bit. Okay, now start condition. You all remember we have 2 lines. One is a serial data line and another one is serial clock line. So start condition means when while you want to check this start condition, first what happened, serial data lines will move from that is high level to low level. Then after serial data line switched, SCL also switched from high level to low level. That means we have to identify its come start condition. Have you seen, ma? I think you can able to see. Just focus. One serial line comes from high to low. Then what happened? SCL also come from high to low. That means it is going in start condition. Okay, now we come for stop condition. Stop condition just reverse. So first what happened? Serial clock line will goes from low level to high level. Once it reaches, then after that SDA line will come from low level to high level. Then means we have to identify it is a stop condition. So start condition and stop condition is from logic level high to low and low to high. Are you clear? The next one is address. I told you actually we have a 7-bit address, 11-bit address is there. So you have seen this is my 7-bit address 11000100. So after identifying my 7-bit address, I can able to understand how many slave devices I have connected. Are you clear or not? So we were saying nearly some 128 devices were connected and all now. So maximum they were saying that 128 devices are connected now. Depending upon some logic frame and all, they have kept some 11-bit address. Okay, so here we have used only 7-bit address. Then read or write, whether I have to read from the line or write from the line. You all understand read slash write bar. That means read is logic level high line, write means logic level low line. So logic level low voltage means I'm going to write in my slave device. If logic level is high means I'm going to read from my slave device. Okay, and this is my data bit. Whether I am going to load and all means write means I will my data byte will move from master to slave. Whether I have to read now, I have to move from slave to master. Okay, so once I have received my data, automatically the acknowledgement will send. I told you there are 2 acknowledgements are there. One is after identifying the address, and the next one is after receiving the data. So people understand what are the data frame in I2C communication protocol, ma? Anyone please tell what are the I2C communication message contains? Yeah, anyone please kindly tell, ma? What are the I2C communication?
start condition,
Um,
address of the slave,
yes,
next
do
read
good.
and write, data frame, acknowledgement or NAC, and stop condition.
Two acknowledgement. One is for
Data
data bit receive
data bit.
and another for checking the address.
Yes, ma'am.
Okay, ma. Good. Vijayshri.
Yes, ma'am.
Yeah, you are only saying. Yeah, good, Vijayshri. Okay. Now you have to understand that this I have explained. Start condition, stop condition, read and write, and acknowledgement bit whether it is successfully received or not. Okay. So now the next one is addressing. So addressing, we all have some addresses. This have a general purpose. Okay. So some of the addresses, the address of the particular slave. So I told you 7-bit address is there as well as 11-bit address. Maximum it can occupy 11-bit address. So you all understand. You understand first. I can able to send only not one single address. I can will send a subsequent address and data to all the devices will be same now. First it will send start, then the first address word, then acknowledgement, then second address word. I think this is example. B1 is my first address and B2 is this next slave address. So till Bn. Have you understand? So you have seen here B1, B2, Bn are the address. That is denoted by yellow color, sorry, green color, and blue color indicates the data. So you always understand that my address also consequently carried by that. So till this is my stop and this is my start and stop. In between that I can put the addresses in sequence. Along with that I can put my data also. Okay. And now you see that this is the thing. We have a two kind of communication. One is you have seen start slave address, write acknowledgement, data acknowledgement, data acknowledgement, end. Sometime what happen na start slave address, read or write, acknowledgement, data, acknowledgement, restart. So it will keep on going. Here also we have seen that here one single slave address and two datas. Are you clear? But here you have seen two slave address, single data. So any possible combination, the I square C communication will transfer the data. That means single slave address, it has to do, communicate two data. One is writing the data, the another one is also writing the data. But here you see the second message, two slave address. But the data is also, they are saying, this is I am reading or writing the data. This is I'm reading and writing the data. But in this both the frame, here it starts now, then here it's end. So I can put n number of slave address inside the start and stop. And similarly, I can put n number of data is also in between start and stop. That is available in I square C. But when you see other communication protocol, if I am transferring one message, that 8-bit na, it before the 8-bit we have one start bit, and after the 8-bit we have one stop bit. But when you go with CAN bit, CAN protocol na, it can able to transfer 64 bits na. Before 64 bits I have a start frame, and after the 64 bits I am having the end frame. But I square C we don't have that. We have a single address and multiple data can be transferred. We can have a multiple address and we can transfer the single data. Both are possible. That in between that I can keep my start and stop bit. Are you clear, ma? Okay. And this is also the same thing they have explained. You have seen this, my start bit. I told you high to low, then only it will reach from high to low. First it will reach from low to high, then only it will reach from low to high. So slave address, the direction of the bit will be there, right, read or write, then acknowledgement, then data bit, then acknowledgement. So this is the communication will be happen. I told you multiple slave address and single data will be there, single slave address and multiple data will be there. In between that I can put a start and stop. In between that I can put any combination of address and data. I can communicate with my slave devices. So this is the thing they are saying. So this is the procedure. Master sends start condition and control the clock signal. Then it will send the 7-bit slave address. Okay. After that, slave will receive or send. That means read or write. Okay, so receive means what? Write. Transmit means what? Read. So that is the thing. So after read or write and all, what we were saying and all, na, it whether my slave addresses match with the 7-bit device address. If both are same now, automatically the slave will send the acknowledgement bit to the master. Once the acknowledgement bit is received from the slave, automatically master will transmit the byte of data to slave devices. So this is the concept we were saying, and this is the procedure. First, master will send the clock signal, then it will send the address. After getting the address, it will send whether it is read or write operation. After sending read and write operation, slave devices will understand, okay, this is my address. Then it will send the acknowledgement bit. Then after receiving the acknowledgement bit from the slave devices, master will send the transmit the data. Okay, so I think this is the same thing. Start, stop, and all same diagram only. I told you start what is the condition, stop what is the condition, and in between it will carry the address and data. Are you clear, ma? Okay, and I told you the same diagram. Okay, SDA, serial data line, serial clock line. And what is this RP? Pull up resistor, which is connected to the VDD. Okay, one master and 3 slave devices are there. Okay, same thing only they are saying. Fast mode, slow mode, and high speed mode and all. Okay, so in I squared properties, what is the thing now? Clock stretching. When the receiver needs a time, for example, it won't to do any problem. It won't transmit anything. It will take the pull-up resistor. That is called as a clock stretching. It is increasing the time period. Then clock synchronization. Okay, when there are two masters are there, definitely my two master has to be synchronized. Then only my slave device will work. If one more staff is coming inside the classroom, I'm saying something, and the particular staff is saying that, you won't give attention to both of them. So what we will do, I will talk at least one at a time. So we have a synchronization between that two. That is the way clock synchronization. And broadcast, I told you the address occupied. Okay, then I square C conclusions. What are the conclusion? It is used for the device that communication occasionally only. So the addressing scheme allow multiple device I can able to connect. That are my advantage. But what is my disadvantage? If I go with a multi-master, that will go with half duplex, and software, hardware, and especially software implementation is more complicated than SPA, because we are seeing full along with hardware concepts only. So software implementation is more concept, not scalable for large number of devices. We have seen nearly 128 devices only connected here. So please students, if they ask I square C protocol, that you have to about the write the introduction. What is I square C? This diagram is mandatory, and this that diagram you have drawn on, no need of this. Pull up resistor, how it is transmitting various addresses, and this message protocol is very very important. Okay, then how it is transferring address, single address, multiple data, multiple address, single data, any combination can be sent. Okay, and this is the communication, how it is happening from master to slave, and then how it is working, same concept only, not much different. And this I have explained with microcontroller master as well as microcontroller slave. So only one master will be there, and another microcontroller will act as a slave only. Okay, I square C property having clock stretching, clock synchronization, and then conclusion. Okay, I think SPI we will while discussing SPIL, we will see how we will move on that. Okay, I think you all understand. In the fourth unit, what will be the question? RS 230 to 485, one question will ask. The another protocol can, one question will be asked. The third protocol is I square C, one question will be asked. So 6 probability question in this unit. 6 probability question. 6 serial communication protocol is there. So we will learn all the 6 serial communication protocols. Is clear, ma? Okay, now I will call. Actually, Neetupri, are you ready, ma?
Yes, ma'am.
Okay, now I will share the screen.
Ma'am, please give
Yeah, I
share
gave
option to
access.
Abhi, ma'am.
Abhiya. Now
Yes,
Abhi is
ma'am.
sharing. Mm.
Abhi, good morning, everyone. Today, let us see an application of where a microcontroller is used in solar field, that is in electrical field. Until today, we were seeing microcontroller applications and all like real-time applications under electronics field and other things. So today, let us see in where in electrical it is used. So my topic is solar energy measurement using PIC microcontroller. So using this PIC microcontroller, we are going to see how we are going to measure solar energy, that is voltage, current, etc. Next slide. So this is the block diagram of it, solar energy measurement system. Here, with the help of voltage and current sensors. One second. Here, with the help of voltage and current sensors, we are going to measure the amount of voltage and current we are getting in the PIC microcontroller, which is displayed in the LCD display. So why we are going to use it, because from the solar panel we should know how much of voltage is being generated. Supposing say in our house there is one solar panel we have kept. So without knowing how much energy or how much voltage it is giving us, we can't use it. So first we should know how much it is generating. So for that reason we are using this concept. Next slide, Abhi. Abhi, can you just bring it down?
Actually, Abhi, you have to zoom it. You can't able to view. The participants
Ma'am,
is.
it's towards one corner, ma'am.
Actually, she has to. Yeah.
Yeah, so from the solar panel, what happens is that we get an analog signal of voltage. And moreover, the voltage will obviously be more than 5 volt. So for a microcontroller, can't read voltage which is more than 5 volt. Hence, we use this voltage divider circuit so that we can reduce the voltage and which is sent to the microcontroller. And the voltage will be displayed in this LCD, like how much volt is being generated. On the other hand, we use these capacitors so that there is no we can reduce the harmonics, and the voltage fluctuation is also reduced using these capacitors. And so the current will be sent into this microcontroller, and we can see how much amount of current is also generated. So with this, we can come to know like how much amount of voltage and current is produced in our solar panel, so that we can know like what is efficiency of the solar panel also. That's all, ma'am.
Okay. Actually, you have taken a very small topic, Nitupriya.
Yes,
Measuring
ma'am.
voltage and current.
But
Okay.
the
Yeah,
thing
tell me.
is, what everybody have done is they are shown in electronics field. Our main thing is electrical. So we
Yeah.
should know first of all with this PIC microcontroller, whatever microcontroller, where we are using an electrical field first.
Yeah. Yeah, that is absolutely
That is
correct.
why I took this. That's why
Yeah,
I took
that's
this topic, ma'am. I know it is small, but we have to know where we can use that first.
yeah, that's okay. But you have used the PIC microcontroller. You have along with the PV panel. You all
Yes,
know
ma'am.
in a PV panel, the controller plays a vital role. We all know while we are tilting the controller, while we are seeing, we have a single axis controller, dual axis controller. At that time also, every time we will measure the power, and according to the direction of the solar and azimuth angle, we will tilt. So you may not only this, it having a various application.
Yes,
Even
ma'am.
when you go with solar panel, one of the technique is soiling. So due to dust, everything present in the solar panel, it will also identified by the microcontroller. So what she had told is very good. She had taken purely electrical side. I'm very happy, Neetu Priya. You
Thank
are
you,
more
ma'am.
interested in electrical and you want to do something in electrical, you'll do it. Okay,
Okay,
good,
ma'am.
ma.
Thank
Then
you, ma'am.
stop sharing this, ma. Yeah. Next, Parameshwari.
Ma'am.
Um, all having Abhinami only. Okay. Smart agriculture. Yeah.
Good morning to all. Today we will see the one of the application of a PIC microcontroller, which is used in smart agriculture using a PIC microcontroller. With the PIC microcontroller, we also use GSM technology. Next slide. Here we use a soil moisture sensor used to measure the moisture in the soil. Next, temperature sensor used to sensing the temperature from the surrounding environment. Then humidity sensor used to sense humidity of the air. Similarly, light sensor used to measure light coming from the sun. Also, we use a GSM module, water motor, and a LCD display. Next slide. All the data from the sensor is given to the PIC microcontroller. Then the data from the sensor is displayed on a LCD. PIC supports serial protocol, parallel protocol, and I2C protocols. PIC microcontroller sets some threshold measure for sensor. If the sensor goes beyond that limit, it means plants are affected by some diseases. PIC gives message with the help of the GSM to the user's mobile. The message gives information about what type of disease is attacked in plants, and also gives a medicine for that disease. Next slide. So this is a overview of the system. Here we can see soil moisture sensor, all the sensors, GSM modules, LCD displays. Next slide. In right side pick LCD display shows light, humidity, temperature, and moisture level of the plant. Then, sorry, in left side pick, in right side pick, what type of disease is attacked the plants, and it gives some suggestion about the medicines. The system helps to improve the yields of the crops and the overall production, since each parameter is sensed by separate sensors. And in PIC and other microcontroller are used in various applications in agriculture. Thank you. Ma'am, that's all.
Yeah, go to your diagram, block diagram. Yeah, moisture. But here, water, oh, that's okay. But one thing you have told me, go to the next one. It is next one. Yeah, you are saying it is identifying disease also.
Yes,
But
ma'am.
the block diagram,
Yes, ma'am.
yeah, I think disease identification. Yeah, tell me, Parameshwari.
Ma'am, if any disease is attacked by plants, it will give message to our mobile, ma'am.
Oh, any how it will identify normally?
Using these sensors, ma'am.
Oh, that is separate sensor is available. I don't know.
Yes,
That's
ma'am.
why I'm asking. Okay, actually, it's a you have taken from paper.
Yes, ma'am.
It is one of the paper. Okay, okay, okay. Actually, there is some lookup table concept is there. So because you see, by you seeing your message, it is identifying disease alert also is coming. Okay, so these are some of the disease. I don't know the exact meaning of all this, but I think it have a some lookup table concept will be there. But the thing is, it is not reflected in the block diagram. Okay, but because it's very good topic, Parameshwari, she had taken in the agriculture field. So we today we have seen so much of field. One of them taken from agriculture, another from spy robot, and another girl taken from solar panel, and then digital camera. So for a useful message, we got it. Okay, ma, stop sharing. Yeah, the next, I think Mogana Priya, she are trying from 3 classes, and today we will see finally, or else I will explain and finish it off. Mogana Priya. Mm. Parameshwari. Mm. Yeah, ma. Directly go to the 5th slide, ma. Yeah, Mogana Priya, I can't able to hear your voice, ma. Mogana Priya. What happened to her?
This is the
I will read out the absentees for the first hour. Anyone please present, kindly will tell me, ma. Register number 5. Yeah, Mogana Priya, what happened? You can't able to. I told you to. Yeah, she's sharing the screen. Yeah, start talking, ma.
TSOP, it is the receiver which is in the television, and PIC also in the television, transistor, relay, and as usual the desired output. In TV remote, there are so many buttons. The manufacturer fixed some different binary values for each button. For example, for volume up button, we will take volume up button. Fix 6. 6 for the binary value of 6 is 0110. Okay, suppose the manufacturer fixed 0110 for the volume of button. So if we press the volume of button, the binary value reaches the LED, which is in the LED will send the binary value to the microcontroller, which is in the television in the form of infrared waves. Then the microcontroller, the manufacturer programmed the microcontroller to accept the binary value and as well as to defetch it to get the desired output, so that the microcontroller will defetch it, and finally the television will change the channel which we like. That's it, ma'am.
Yeah, okay, Mogana Priya. So you have prepared, so for that you have taken good applications. Okay. So now I will, yeah. What, Mogana Priya? Listen, ma, I will tell you the absentees for register number 5, register number 9, register number 14, register number 17, Register number 22. 22 is absent, I think so. Okay. Then register number 26. Then register number 28. Then the next absent is register number 48. Register number 50. And register number 52. Register number 55. 55, Bonu Prakash, he didn't come. Okay, register number 55. Then register number 62. Then register number 64. Then register number 67. Then register number 83, 89, 93, 7
Ma'am,
not.
89 present, ma'am. We don't have network, ma'am, power, ma'am. So
Whom?
Santosh Reddy present, ma'am.
Present. Okay.
Yes, ma'am.
83. After that 93. After that 702. Then Shalini Vijay Kumar. Okay. And I told you next class Avinash, Chandralekha, Shushant, Deepa K, Deepa S. So kindly prepare for the seminar and come. Students, I didn't receive an assignment. You all know 14th we have to submit the assignment. Those who have explained the seminar, kindly draw the block diagram and write it in part 5 questions. Remaining the questions are very easy. What we discussed in the Kavot only, the same question only we people were discussing. Are you clear, ma? So prepare well. And okay, I think the sir will come.